All right, so this is 12-1 probability events. To start off, number two, explain what it means for two events to be overlapping. That means they share a common outcome. That's all it means. Share a common outcome. Not necessarily dependent upon each other, but to some degree they are. All right, let's do a couple of these. Let's see here. Now, it talks about up in the instruction set here that events A and B are disjoint, which means independent, for 1, 3 through 4. Find the probability of A and B. So these are independent events, and that's really easy. Probability of A or B is simply 0.11 plus 0.19. That's all it is. Let's be the plus. It's a horrible looking plus. So anyways, we have 0.30. All right. Over here, they're telling us that these are overlapping, and you're supposed to find the probability of A and B. The probability of event A and B is going to be the probability of event A plus B minus the OR statement, 0.2. And that's going to give us 0.5. This stuff's not too hard. All right, moving on to the next group. A bag contains 10 pieces of paper numbered 1 through 10. You draw one piece of paper at random. Find the probability of A or B for the given events. All right, so I'm just going to write out my sample space because it's the easiest way to do this thing. There's a lot of kids who won't do that. It's just too much work. Event A is the number is at least 6. At least 6. So that's going to be all of those guys. All right. There's 5 of them. So the probability of event A is 5 in 10. I'm supposed to find OR B, which means add. And event B is the number is odd. Now, when you talk about this, you don't want to include things twice because there is overlap. So you really don't want to include things twice. If I do include them twice, I have to take them back away. But there are 5 odd numbers. But then I have to take away the overlap, which was 2 of them. I'm this or that, but not both. Okay, it can't be both. Anyways, I get 8/10, which is 4/5. So, do the same thing over here on 8. Draw out the solution space. Remember, take away the overlap. All right, let's see. We've got a little spinner over here. So let's look at 10. Event A, a spinner lands on an even number. Event B, the spinner lands on blue. Along the top, we're finding the probability of event A or B, and the word or means add. So an even number, what do we got here? We got 1, 2, 3, 4, 5, 6. Looks like there's 6 evens, right? 1, 2, 3, 4, 5, 6. I'm assuming out of 12. All right, so event A, the probability of event A is 6 in 12. And event B is that we land on a blue, 1, 2, 3, 4. And none of those were even. So I don't really have to do anything with that, but it's just 6/12 plus 4/12. And then I put them together and I get 10/12, then I reduce it down to 5/6. Well, that was easy enough. What do we got going on here? Moving on to a chart. A blood bank records the blood types, including positive or negative, during a blood drive. The table shows the number of donors with each type of blood. Find the probability that a donor chosen at random has type O or AB blood. So at random, we have type O or AB, and those two events don't overlap. You can't have both, right? So type O is 172 out of 400 plus AB, which is 21 out of 400. And then we just add things together. It's not rocket science. It's 190 what? 2? 3? Yeah, 193. And I don't feel that that will simplify. Deep in my heart, I don't think it will. Now you got to be careful on some of these. Like 13's a little tougher. 13's got overlap. I don't want to do all of it. Let's see, we have a pie graph here. The estimated percent age distribution in the U.S. population for 2010 is shown in the circle graph. Find the probability that a person chosen at random fits the data. Like, none of this is difficult. It's really not. I'll just do 17, that they are from 25 to 44 years old. Well, that means I'm going to have to add those two together. 26%. All right, let's look at 19. Of 200 students at a school, 58 play football, 40 play basketball, and 93 play both. What is the probability that a randomly selected student plays either football or basketball, but not both? So these do have overlap because we talk about playing both. So we got to follow a formula here. Probability of, I want to know or, right? Football or basketball would be the probability of playing football plus the probability of playing basketball. Take away the probability of both, F and B. Now, it says 58 play football. So that's going to be 58 in 200. There's 200 kids. The probability of playing basketball is 40 out of 200 kids. And 93 play both. So we're going to take away 93 out of 200. And this is going to get the or statement going on. The kids who only play one sport but not both. And it's not that many because 58 and 40 is making 98. 98 minus 93 is 5. So it's 5 in 200, which you should reduce down to, what, 1 in 40? Easy peasy lemon squeezy. See, 21's up next. You roll a 12-sided die and it has faces numbered from 1 to 12. What is the probability that in a single roll you roll an even or a multiple of 3? Sample spaces are really the only way that I can show you what's going on in my brain. And they just make sense to do it. So the probability of rolling an even would be a 2, a 4, a 6, an 8, a 10, and a 12. It's half of them, right? There's 3 of them. So it's going to be 6 in 12. Now, make sure that you don't double count because there's going to be some overlap here. The probability of rolling a multiple of 3, well, that would be 3 and 6, which I've already counted for. 9 is new, but 12's already been talked about. So I'm only adding in 2 more things that I haven't already talked about. So plus 2 and 12. And that's going to give me 8 twelfths, right? 6 plus 2 is 12. Both divisible by 4, 2/3. 2 and 3. Let's see, here we have our complementary events. You're supposed to find the probability of not A, and the probability of not A is simply 1 minus the probability of event A. So this is just going to be 1 minus 0.37, which is 0.63, which would look a lot cooler as 63 over 100, let me tell you. All right, the last one I feel like doing would be number 25. The sum is neither 2 nor 12. I'm going to pause real quick and type some stuff out. BRB. So I paused it so you guys could see the sample space. And the reality is you should probably spend some time and write down the sample space instead of just taking credit for and doing absolutely no work. But you're not going to because you're lazy. That's the reality of it. So anywho, the probability of having a sum equal 2 is not going to be very, like it doesn't happen very many places, right? It happens exactly right there. There's a 1 in 36 chance because they both have to be a 1. There's only a 1 in 36 chance of this event happening. So this is 1 in 36. Now the reason I have the plus sign here is because that's the word or. And there you go. A sum of 12, there's going to be a couple things that get me 12, aren't there? Well, actually, there's not going to be hardly anything that gets me 12. It's going to be a 6 and 6. And that's pretty much it. So plus another 36. And now I'm good to go. So what I end up with is 2/36, which is an 18th. Now, what I just found was this guy right here. This is the complement of that. All right. So the probability of not, well, whatever, not 2 or 12 is simply 1 minus 1/18. Now, 1 is 18/18, and 18/18 minus 1/18 is 17/18. Anyways, that's it. That's all I got for you. Hope it was enough.